It's one of the concepts that we have to understand. ANOVA. Why we have to use ANOVA? ANOVA is a one-way analysis of variance. The problem here that we need to determine if there is a significant differences between the means of NO2 concentration of the car, minibus, and bus. Of course, NO2 is in part per billion in the exhaust fumes of vehicles. So the analysis of variance, or ANOVA, is a test to check if there is any differences, statistical, of course, differences, between the means when you have 3 or more. Now, remember we did the student test before. Now you have 3, column 1, column 2, and column 3. 1 for car, 1 for minibus, and 1 for bus. We're going to do the same thing here, but now we're going to apply a one-way factor. Okay, this factor is NO2 concentration in part per billion. We should do the same thing. The null hypothesis is not that there is no difference between column 1, column 2, and column 3, which means mu1 is equal mu2 is equal to mu3. We're going to use the process, and we're going to check P, and we're going to check F statistics and F critical, and then we're going to compare them all to find out if there is a significant differences. If H naught is rejected, then we should go to an alternative hypothesis, H1. So mu1 is not equal to mu2, not equal to mu3. So there is, if H1 is accepted, then there is a difference between the 3 columns, car, minibus, and bus, due to a factor. So we call this a one-way ANOVA. So the one-way ANOVA will find out the F statistics, which is simply the ratio of variations between sample means to the variation within the samples. If this ratio is really high, which means H naught is weak, and we cannot trust H naught, we have to go to H1. Now, we did the t-test before. And t-test is a very good test to detect statistical differences in mean between 2 populations. But if you are analyzing for more than 2 groups, it is strongly recommended to use ANOVA instead. So for 2 columns, use t-test. لأن الآن تبدأ العملية, now it become what? Because multiple t-test increases the chances of type 1 error, which is the incorrect rejection of H naught. So more than 3 or more, use ANOVA. So let's go to data analysis. And we go to ANOVA single factor, NO2. We don't have more than one factor. Okay. The input range. And let's put it with the title of the column all the way down. Columns labeled in the first column. Of course, we are using 95% confidence, and the output range, we'll have it here. Very simple, very simple. So now we have so this is ANOVA, and then we should now try to analyze. Of course, here you will have the average of the car, the NO2 concentration average 67.5 part per billion versus minibus 51 or 52 almost part per billion, and bus 42 almost part per billion. These averages, are they statistically significant? First of all, we have to look at P. Okay, let's look at P here. You look at it by looking at this P value. We look always of anything below 0.05. This is F is 2.45 10 to the minus 17, which shows that it is statistically significant. And now let's look at the F. The F statistics is 151, higher than F critical, 3.3, which means that this will confirm that the differences between the three columns, car in NO2 versus minibus in NO2 and part per billion, and bus at the end, minibus and bus, are all statistically significant. Now, they're all different, but later on we could find out between column 1 and column 2 to see the difference. In total, there is a statistical differences according to the 95% level of confidence levels. Now, let's do it between car and minibus and see. So we go to data analysis, single factor, column, labels, and output. And let's put the output here. And see. 1.5 10 to the minus 9. So it is also statistical significant between car and minibus. Let's do it between car and bus, or minibus and bus. Let's say minibus and bus. So we do data analysis, single factor, columns, labels, 0.05, and then we select okay, so now we have minibus and bus, and you can see they are also statistically significant at 95% confidence of levels. So now let's check between car and bus. You will have the same thing, that they look like, I checked this before, and you could apply the same method and you'll find that there is a statistical significance between also car in NO2 concentration and part per billion versus bus in NO2 and part per billion. So I'll stop at this point, and hopefully ANOVA is very simple, but it's an important concept that we have to know. Okay, so we'll see you. Let's see. We'll see you next concept.